Bueno, paso ahora la palabra a Miguel Ruiz Cruz, que nos va a presentar su trabajo sobre in vitro pharmacogenic activation of arcuate POMC neurons reveals their potential role in transmitting energy status to the reproductive function.
Okay, good morning, and thanks for the presentation. First of all, I want to thanks to the scientific committee for choosing my presentation for our communication. I am from the group of hormonal regulation of energy balance, poverty, and reproduction from the MIGUEL of Córdoba. As introduction, the reproduction is a function indispensable for the perpetuation of the species, and since it is an energy-dependent function, it is only maintained in conditions of energy sufficiency. Therefore, there is a close relationship between reproduction and metabolism that was already perceived by the human beings that lived during the Paleolithic age, who represent this fertility as overweight women. In this sense, the metabolic information is integrated for the control of reproduction thanks to the existence of a complex network of neuroendocrine circuits which are composed by many neural populations located in the hypothalamus that acts as receptors for metabolic peripheral hormones such as leptin and insulin that has the ability to inform about the metabolic state of the body. Ultimately, all the neuroendocrine circuits converge to regulate the activity of the so-called reproductive axis, which is composed by GnRH neurons, which secretes the gonadotropin-releasing hormone, the pituitary, where the secretion of the GnRH stimulates in turn the secretion of gonadotropins, which are the luteinizing hormone, or LH, and the follicle stimulation hormone, or FSH, which travels through the systemic circulation until reaching the last component of the axis, the gonads, where they stimulate the gametogenesis and the secretion of gonadal hormones. In this context, this work is centered in the study of the POMC neurons of the arcuate nucleus, which is one of the populations that had been proposed as responsible for integrating the metabolic information for the control of reproduction. POMC neurons express the propimelanocortin gene, which encodes a polypeptide precursor, which is proteolytically cleaved to generate several neuropeptides, such as melanocyte stimulation hormones, alpha, beta, and gamma, also known as melanocortins, as well as beta-endorphin opioid. Arcuate POMC neurons has a prominent role on energy homeostasis and metabolism. In this sense, they are widely known for their anorexigenic function, being activated after meals to promote satiety and an increment of the energy expenditure. Clear evidence of this is that mice with congenital deletion of the POMC gene develop hyperphagia and obesity. Regarding the role of arcuate POMC neurons in reproduction, most of the evidence to date is based on pharmacological studies in which the neuropeptides and neurotransmitters that POMC neurons secrete has been administered in isolation, studying their effects in vivo on reproductive parameters such as the LH levels, in addition to in vitro electrophysiological studies in which there has been studied if the electrical activity of GnRH neurons change this activity in response to these same neuropeptides or neurotransmitters. In this sense, regarding the neuropeptides synthesized from the POMC gene, it has been found stimulatory effects for alpha-MSH, but in the opposite direction, inhibitory effects have been described for beta-endorphin over the reproductive axis. In addition to the fact that two neuropeptides synthesized by the same neurons has opposite effects over the reproductive axis, it has to be stressed that POMC neurons other neuropeptides and neurotransmitters. Among we can find CART and glutamate with the stimulatory and GABA with inhibitory effects reported over the reproductive axis. In this sense, pharmacological studies provide fragmentary evidence that does not explain all the complexity of the system, since we know the effects of the neuropeptides and neurotransmitters when administered in isolation, but we don't actually know what's happening in vivo when arcuate POMC neurons are activated and all of these neuropeptides and neurotransmitters are released at the same time. Fortunately, in recent decades, new techniques have emerged, such as pharmacogenetics, which allow us to provide answer to this question. Pharmacogenetics is a technique based on the expression of DREADs, which are G protein coupled receptors that has been modified to respond only to a specific ligand. This is the clozapine N-oxide or CNO. In this work, we use an activator DREAD, which is called HN3DQ, that is coupled to GQ protein, and after the binding to CNO, will produce an increment on the intracellular concentration of this, in the context of a neuron, will produce their activation and the release of the neuropeptides and neurotransmitters. In this context, the objective of this work was to set up a protocol for the in vivo activation of arcuate POMC neurons to evaluate the consequences of such neural activation on the reproductive axis. To achieve this, we first injected POMC mice with adeno-associated viruses overexpressing the DREAD activator HN3DQ in a dependent way. So only POMC neurons will be infected. And this injection was released in the arcuate nucleus specifically. After 3 weeks, the period necessary for achieving the proper level of expression of the receptor, we administer CNO to produce the DREAD-mediated neural activation. Then we take several blood samples over a period of 2 hours, and we perform ELISA to measure the levels of LH as a surrogate marker of the activity of the reproductive axis. This allows us to evaluate the temporal profile of secretion and to calculate the net secretory mass of LH in this 2-hour period by the calculation of the area under the curve. Then, 25 hours later, we measure food intake to determine if the activation of POMC neurons induces satiety. Finally, to confine the correct expression of the viruses, we extracted the brain and processed it for the immunohistochemical detection of the HN3DQ tagged reporter protein mCherry. Now that we are in context, we can proceed to see the results. First, we were able to validate our protocol for the pharmacogenetic activation of POMC neurons since the administration of the DREAD agonist CNO produced the expected decrease in food intake, given the well-known anorexigenic role of POMC neurons. Then we wanted to know if the pharmacogenetic activation of POMC neurons has any effect over LH secretion. We can see here the average profiles for all the mice used in this study. You can see with a red line the profile of LH after the administration of the DREAD agonist CNO, and in black the profile corresponding to the administration of saline as control. Visually, we can see an increment of the LH secretion over time that peaks at 80 minutes. Then the analysis of the area under the curve confirmed that the net secretion of LH during this 2-hour period was higher after the administration of CNO. Here we can see some representative profiles. Mice number 1 corresponds to a POMC injected with the viruses, which showed response after the administration of CNO. And the mice number 2 is a negative control consisting in a wild type injected with the viruses, which showed no response after the administration of CNO. To finish, we perform immunohistochemistry of the reporter protein mCherry to confine the presence of a considerable number of infected neurons in the arcuate of POMC injected mice. Here you can see the pictures of the same mice that I showed before. We can see that the mice number 1, which is a POMC injected mice, has a pattern of expression to that described for POMC in the literature. However, the mice number 2, which is the wild type injected with the viruses, showed no positive neuron in the arcuate. Overall, this finding supports the specificity of our protocol for the pharmacogenetic activation of arcuate POMC neurons. To sum up, all results suggest a potential role of arcuate POMC neurons as activators of the reproductive axis in conditions of energy sufficiency. Finally, I would like to thank my research group for their support and you for your attention. Thank you.
Thank you so much for your explanation, Miguel. I wanted to ask you what's your future perspective about your study? And
Sorry, can you repeat?
what's the future perspective for the study?
You mean the future experiments that we are planning to?
Yes, yes.
We have documented that the activation of POMC neurons with this pharmacogenetic approach produce an increment of the LH secretion, but we still have to characterize the neuropeptides and neurotransmitters that are implicated. So we are planning to use antagonists of, for example, the alpha MSH to determine if after the administration of the antagonist, this stimulation is blocked. And we also have planned to perform optogenetics instead of pharmacogenetics, because this technique allows us to modify the activity of POMC neurons in a more temporal, precise way, since it is activated by light instead of the injection of a pharmacological ligand. And this also allows us to play with the frequency of activation, since it is reported that higher frequencies of activation produce the secretion of neuropeptides, but lower frequencies of activation will produce the secretion of neurotransmitters instead of neuropeptides. So it will be the future perspective.
Tenemos otra pregunta. ¿Cuántas inyecciones de AAV y qué cantidad administráis de adenovirus?
El número de inyecciones fue de una sola inyección en el arcuato de forma bilateral, e inyectamos a un título de 10 a las 12 partículas por mililitro virales. Y con una simple inyección solo es necesario esperar 3 semanas para poder empezar con el protocolo de activación.
Vale, perfecto. Muchísimas gracias por tu exponencia y enhorabuena.
Muchas gracias.